Hi, in this lesson we're going to learn about multiplying and dividing radicals. We typically do this after addition and subtraction of radicals. To multiply, what we do is we multiply coefficients, the numbers outside of the radical, as one component, and we multiply the radicands, the things inside the radicals, separately. What's outside stays outside, what's inside stays inside, if you will. There are some important patterns that you should have learned in the past that will come up when you're working with multiplying and dividing. One is the distributive property, shown here. A value A times B plus C expands this way. FOIL, which is an extended distributive property, representing first, outer, inner, and last of a binomial and a binomial, produces this multiplication pattern. Binomial squares, where I have two terms combined by addition or subtraction, that's what I mean by the plus minus, two different formats possible. When it's squared, it produces a trinomial. People often miss that middle term. If you're unclear on that one, show the work in longhand form to confirm for yourself that that's the case. Also, binomial sum and difference, where I have binomials that are identical except for the middle sign. They produce a difference of squares. Okay, we're going to work through several examples now. First, we have a coefficient -2 and a coefficient -4. So when I'm simplifying this, I can combine those portions first, then look at the radicals, seeing that they're both cube roots, so they're like each other in terms of the index. So I'm going to combine 4x squared with 6x squared, all inside of one perfect cube. Okay, well the coefficient becomes +8. Inside I've got 24. And I'm going to think of 24 as being a cube and another factor. Okay, so I'm going to write that as 8 times 3, and x exponent 4 can be written as x cubed times x. So I'm going to write it that way. And you'll see why in just a second here. There. Okay. See, I now have a cube root of a cube. So the cube root of 8 is the number 2. The cube root of x cubed is the expression x. I'm left with a 3 and an x inside the radical, and it's a cube root, so don't forget that. Lastly, I write 16x, cube root 3x. Oh, and I'm just going to add a comment here. Variables are positive. Okay, so we're not going to worry about the absolute value of x and all that discussion that's occurred in the past. All right, let's look at this case. Example 2. Now I've got a radical plus a value, a radical minus a value. If you look up above here, that's this sum and difference pattern. A plus b, a minus b. Let me rewrite that down here. I've got something of the form a plus b times an a minus b, which makes an a squared minus b squared. We want to take advantage of these shortcuts. Well, this is like my a, and this is like my b. See it? So I'm going to write my a squared minus my b squared. Now the square and the square root are inverse operations, so they cancel. 4 squared is 16, and I subtract that result. So my final answer is x minus 19. Not too bad, actually. Let's check out this one. I'm going to change this problem a bit here. Let's make this 4 root y. Okay. And I just did that because otherwise this pattern was very similar to what I did before. In fact, you know what? I'm going to change it again. I'm going to change this so that we practice a binomial square. Now, look up above. A plus b all squared makes this trinomial. This is the kind of idea that I have here. A plus b all squared makes a squared, 2ab, and b squared. So I want to take advantage of that pattern. This is my a, this is my b. So I'm going to have the root of 2x squared. Then we have 2 times my root of 2x times my root of y. then I'm going to have the root of y squared. Okay, the square and the square root are inverses that cancel. These are both radicals with index 2, so I can write 2xy all inside of one radical. And y squared square rooted, again inverses that cancel. We're done. These are unlike. I can't combine these or do anything else with them. So that's as far as we can get in expanding that one. All right. Now, in terms of division, here's an important idea. Rationalizing denominators. You need to know or remember that irrational numbers have the form where there are radicands that are not perfect squares that are put inside of a radical of index 2. So an example of this might be the square root of 3. 3 is not a perfect square. The index is 2. So I'm talking about squares and square roots. I can't reduce that. Therefore, it's irrational. It's going to present as a decimal that never stops and never repeats itself. This would also happen with a radicand that isn't a perfect cube put into a radical with index 3 and so on. All right, that's what irrational means. So rationalizing is the process of making an irrational become rational on a denominator. This is what we require in final forms of expressions that are written. Denominators need to be rationalized. So what we need to do is multiply to remove the radicals. I have a couple of examples for you. Okay, here is a monomial denominator. It's just got one component, and it's root 6. If I multiply root 6 by root 6, I would produce the result of 6, because I get root 6 squared, or just 6. But I can't just multiply a denominator without changing the expression. I get a new expression. What I need to do is I need to multiply the numerator as well, because this whole fraction that I just wrote equals 1. And we're allowed to multiply by 1 without changing the value of something. The numerator then is 3 root 6. So I'll write 3 root 6 here. Now notice that 3 is a factor on the numerator, and there's a 3 factor in 6. So I'm going to divide the 3 out, and finally write root 6 over 2. And this is rationalized on the denominator. So that's my goal, is that the denominator wouldn't have a radical. Those ones are fairly simple. The more difficult ones are when your denominator is a binomial. Now we're going to take advantage of this pattern. When we have a sum and a difference of binomials, we get a difference of squares. This second binomial is called a conjugate, by the way. Okay? It's an important term to remember. Okay, here's a binomial denominator with radicals, so it's irrational. The conjugate of this has a plus sign. Okay, so this is what I'm going to want to multiply by, but I need to multiply by this value on the numerator as well, because again, this fraction now equals 1. All right, so I've got 2 terms times 2 terms on the top. I've got root 5 plus root 3 numerator all squared. Notice how they're identical in this case. On the bottom, I've got a root 5 minus root 3 and a root 5 plus root 3. I just wrote it this way to make sure it's clear for you. Okay, we're going to take advantage of 2 patterns though. On the denominator, I'm going to use this rule up here, and I'm going to say a squared minus b squared. That's the denominator simplified, or mostly simplified. The numerator is a binomial square, so I'm going to have root 5 squared, 2 root 5 root 3, and root 3 squared. All right, one more step of simplification. I've got 25, I've got 2 root 15, and I've got 9, pardon me, I've got 3, be root 9. And on the denominator, I've got 5 minus 2. 3, having trouble here. All right, the 25 and the 3 combine to make 28 plus 2 root 15, and the denominator is 2. Almost done. It's now rationalized, so that's good. No more radicals. But now I just have to do some tidying up and simplifying. Look at the 28, the 2, and the 2. There's a common factor of 2. Let's factor out a 2 on the numerator. It's going to look like that. Now, that's multiplication. The line means division, so if I divide everything by 2, I'm going to end up with 14 plus root 15, and that's my final answer, and I don't even have a fraction anymore. Alright, that's the basic ideas of multiplying and dividing.